தெரியுதா?
சூப்பர்.
ஓ, எனக்கு தெரிய மாட்டுது. இந்த வர ஒரு நிமிஷம் இருங்க.
ஓகே.
Sir, good afternoon, sir.
Madam, good afternoon, madam. Welcome, madam.
Thank you, sir.
2 more minutes, madam.
Okay, sir. Okay, sir.
Sharply at 2 p.m., madam. Please, madam.
Okay, sir. இன்னைக்குன்னு இல்லை, என்னைக்குமே வந்துட்டு எல்லா ஒர்க்குமே உங்களோட ஒர்க்கு அப்புறம் அப்படிதான் இருக்குது.
Kindly mute, madam. Kindly mute the microphone.
Camera off பண்ணிட்டு அந்த சைடு போயிடுங்க.
அவ்வளவுதான். Dr. Vinayamurthy is okay now?
Okay, sir. Double okay, sir. Great, sir. Excellent.
Okay, start.
Okay, sir.
கேமரா வேணும். கேமரா ஆன் பண்ணா தான் போயிருது.
Good afternoon to you all. Now may I request Dr. G. Kanagavalli madam to deliver a welcome address. Please, madam.
Thank you, sir. Good afternoon to all. The most respected resource person, Dr. C. Vedirajan, sir, respected professor and head of the Department of Commerce, PC officiating committee member of syndicate, Professor T.R. Gurumurthy, sir, my dear colleagues and dear participants, welcome to all. On behalf of Department of Commerce and on my own behalf, I have the great pleasure of introducing the resource person, Dr. C. Vedirajan, Professor and Head, Department of Corporate Secretaryship, Azhagappa University. Teaching experience 23 years, research experience 19 years. Additional responsibilities, Equal Opportunity Cell Coordinator, Practical Training Coordinator, areas of research, corporate finance, corporate taxation, investors protection SEBI, customer relationship management, women entrepreneurs, HRM competencies, corporate social responsibility, corporate financial reporting, environmental protection, corporate stakeholders interest, achievement awards. UGC Research Award 2015 to 2017, Best Paper Award, All Indian Accounting Conference School of Management, University of Rajasthan, Jaipur. Best Paper Presentation Award, International Conference, Department of Administration, Annamalai University, 2010. Azhagappa Excellence Award for Research, 2018. MTC Global Distinguished Management Teachers Awards, 2018. I welcome Dr. C. Vedirajan, sir, to deliver his special lecture on hypothesis testing 2. I welcome you, sir.
Thank you, Dr. Kanagavalli, with this brief introduction about me. Good afternoon to one and all this online portal. Most respected the program coordinator and the deputy coordinator, Dr. G. Vinayamurthy, Department of Commerce Alapa University. Learned faculty colleagues of this Alapa University and various universities all over India. I am very happy to share this a second turn to me, Hypothesis testing 2 on this portal. And now I am going to do for this, deliver this hypothesis testing 2. Because today we have uh, very, very auspicious day today. All of you, happy Vinaya Chaturthi. And we have a, even though this, very important day today, the Department of Commerce, they are continuously doing exemplary and the activities of research methodology and data analysis, sponsored by ICSSR. So I am very much thankful to the organizer of this wonderful workshop. Let me move to this my part hypothesis testing. The last class we discussed the hypothesis testing 1. Now we have a entirely different area in which we are going to do for seeing this slide as well as my own observation of this statistical methodology. Friends, so this is a testing, hypothesis testing. What are these things, what are the procedures for testing of hypothetical tests? You studied some kind of parametric test, non-parametric test. Then why you applied for this parametric and non-parametric test, and you have correlation, regressions, and some other discriminant analysis. Then totally we have to test the hypothesis. Then only the ultimate results for that every researchers come to this conclusion. In this way, because it is most important for applying for statistical tools. Why you are applying statistical tools? Then is it necessary for the testing the hypothesis? Because this is a statistical inferences, and normally you have to see that. This is one kind of the branch of statistics which is concerned with the using of the probability concepts. When you talk about this, the probability concepts comes under this sampling distribution. Normally, sampling distribution. Many of you knowing a sampling distribution, but is required probability concept tools with uncertainty in decision making process. Normally, we have the process of selection and using of sample statistics. You draw the inference about your population, the parameters which is used based on the subject of and sample drawn from this population. Normally, sampling distribution is the probability distribution. Normally, a probability distribution of a statistic uptime from the large number of sample drawn from a specific population. Large number of samples drawn from a specific population. So this is it. It is a probability distribution of a statistic obtained from a large number of sample drawn from a specific population. The sampling distribution of a given population is the distribution of frequencies of a range of different outcomes. So that would possibly occur for a statistics of a population. How? Because the population may refer to on this entire group of people, event, and maybe objective, or it may be for visit to the university, visit to the department, visit to the hospital, visit to the particular government offices or private offices. So this is, we have to measure that because of this population, we have to refer to this entire group of people, and that is that objectives, event, then we have to commitments. So all these things, this is comes under this for sampling distribution is the most important part for our hypothetical testings, because the populations, this comes under this the probability distribution. Why I'm saying this, this is required for this Then come to this next part, hypothesis testing. Some hypothesis about, parent population. Okay, and from this sample strain. So we have some kind of testing of parent about this parent population from the sample strain. Then we have the second part is estimation. The most important hypothesis testing as well as estimation, the use of statistics obtained from the sample as estimate of the unknown parameter of the population from which the sample is drawn. So this estimation and the point of parameters and pointing of estimations we have to ascertain for this purpose, for calculation of and applying for the hypothesis in terms of simple is drawn. So both cases, the population problems at hand and structured in such a way that we have to inference about this relevant populations values can be made from the sample data. So this is we required for this hypothetical testing and all. Come to this, hypothesis testing. Even though we in last class we discussed these things we is required for hypothesis. What is normally hypothesis? We have to see the hypothesis. We have begin with an assumptions. It's called as hypothesis, and make use of the population parameter. So the population parameter we have to obtain for this inverse. Hypothesis is an submission of this mode and this best of the reasonings, and also for taking this part. Some of the others has to it can be photo out this what you say this hypothesis. We have to obtain. That is we have in statistics is simply a quantitative statement about these populations. It may some consideration for this some kind. How you are going to obtain for that hypothesis? It may be for statistics a simple quantitative statement, and we have to find this this what it says is unchanged series of this thought. Iceland is the uncharted, as well as we have to moving to this part. Is thought to be used as space of consolidations and reputation as we advance in terms of some others is pointed out, but we have to see that the hypothesis is supposition made as the basis for reasoning. That's basis for us as a reasoning. Then we have to see that how we are going to see that this hypothesis we have to testing we have several times, and it may be for used. For example, a coin may be tossed and we have to 100 times. It may be happened that result is 50 70% is a hurt and 30% as what is a type. So this is we have to find, because that is hypothesis testing is a coin is unbiased normally. When 100 times you are tossing. Okay, what will happen this? It may be 50-50, some probability, or it may be for 70-30, a hurt and tail. Likewise, we have to see that, and we have to obtain these results. Population which has to be used for these studies. This is most important, friends, for this procedure of testing hypothesis. Most important, set up the hypothesis. So how this first thing in hypothesis testing is to set up hypothesis about this population parameters. How we are going to set up the population parameters? They collect the sample data, which means sample data, produce sample statistics, and its use of the information to decide how is likely it's that our hypothetical populations. So because it is we have to find this populations, this parameter, it may be for observed and expected. That is a difference, observed and expected differences, setting up hypothesis. So what is the things we have to assume that certain values of the population, what you say that sample data, and determine this difference between these hypothetical values as well as the actual values. So observed as well as the expected. Okay, so this is we have to sample mean. So what is the judgment, which is whether there is any difference, difference in significance, either the small in difference or large in difference, it is likelihood by way of that informations we have, how you are going to value for this length is correct or wrong. So the larger is a difference, the smaller is a livelihood. It depends the values of this. But whereas we have to find this hypothesis, we have a setup of hypothesis. We have conventional approach normally. So the hypothesis we have testing is not to construct a single hypothesis about this population parameter, whereas but rather to set up two different hypotheses normally. As a scholars, is known very well about this hypothesis must so be constructed that if one hypothesis is accepted and the other hypothesis is rejected, very well. So because it is a hypothetical system, when we have to draw the inferences and based on the population parameter, both rather to set up, that is a set up a hypothesis. Please understand this point, friends. Set up the hypothesis, the population parameter. So to construct a single hypothesis about the population parameter, but rather to set up two different hypotheses. The hypothesis must be so constructed by way of one is accepted and one is rejected. So this is called as null hypothesis as well as alternative hypothesis. Okay. So how we are going to for using this null hypothesis is very useful. People are using there is null hypothesis, that's not one, that's not task one, no. So you have to set up the hypothesis based on the population parameter. So you have to construct how you are going to construct null hypothesis. A very useful tool for testing significance of difference. Then in this simplest form of hypothesis assert that there is no real difference in this sample and this population in this particular matter under consideration hence the word null. Okay, the word null, which means that what? Null hypothesis. Anybody should know. The word is null means what you are going to construct. It is a void. It is a void. It is void. That means what? It is a invalid. In other words, invalid. So void or invalid or amounting to a nothing. So this is called as null. So from this word null, it is invalid one or void, or it may be for amounting to nothing. So in that the difference is found is accidental or unimportant arising out of this fluctuation of sampling. It may be accidental or it may be for unimportant because of this fluctuation of sampling. So null hypothesis as a scheme to the legal principles that a man is innocent until he is proved guilty. So in that way, it is constitute challenges by way of functions of the experiment. How we are going to experiment to give this fact to change, and we have to refute or to fall to rebut, or it may be for this challenge. So for example, we want to find out whether the extra coaching has benefited to the students. We have to find extra classes. You have to take the extra classes to the benefit to the students. You have to find because of maybe for tell students. Some kind of the function of the experiment. We have to see that what example, if you want to find out whether the extra coaching has to be benefited to the students in the classroom. So we have to we shall set up a null hypothesis. So how extra coaching has not benefited the students. That is whether we have to see that. For example, another important quite example of this COVID-19, whether the vaccination dose to the students for to save their disease, COVID-19 disease, whether you have to test or not. You have to, because of vaccinated students, we have have a healthy body or not. Okay, so we have a trial in the sense we have to find because of this the truck is truck because of the particular drug is effective in curing of COVID. You know, the Covishield and Covaxin, the particular drug, it is more effective, effectively to cure the COVID-19, isn't it? So you have because we have to study about this such kind of things because when the drugs is not effective, what the ultimate result, the drugs is not effective in curing COVID. Whether the drug is more effective for drug is whether drugs to the students were more effective for this COVID, whether or not. So you have to test the null hypothesis. What's the results we have? Drug is not effective in curing COVID. So this is we have this the rejection in null hypothesis. Rejection in null hypothesis. Which are hypothetical values. Hypothetical values for we have to find this systems. We have to actual values and hypothetical values to find the system. We have to assess the rejection of null hypothesis. This is for this set of hypothesis. Normally, we have to see whether there is any difference. Quite difference between this. So because of due to this some kind of acceptance and rejections of null hypothesis, we have to due to the change or to be changed in this since the many practical problems which has to be established, and we have to find out the statistical significance of difference, either may for rejection of the null hypothesis may thus indicate the success in statistical projects like this. So this is we have to slide, we have find out null hypothesis. Alternative hypothesis, we have to against this null hypothesis, the alternative hypothesis specify those values that are researchers believes to hold true or not. So these values that are researchers believe to hold true and are of course hopes that the sample data lead to acceptance of hypothesis as true. So we have to find this hypothesis merely, and we have to obtain make this difference as to which this hypothesis is called. We have sometimes this alternatively null hypothesis is not alternatively for alternative hypothesis. We have quite difference. Usually it's accepted common practice now. Practice not to associate any special meaning to these null or alternative hypothesis, but merely to let us how to these terms represent to different we have to assumptions about this population parameter. Then we have to see that however as a statistical convenience, so it will make a difference as to such we have the hypothesis called as null hypothesis or alternative hypothesis. So it's not mu, that is this hypothetical values is equal to 100 is null hypothesis. Then HA, that is alternative, means is not equal to 100. So why we are saying this equal? See, we have a 100 times you are tossing a coin 50-50. It's a probability chances, probability of distributions. The population distributions we have to ascertain. It may be for a chance, by way of chance. It may be assumption which is regard to this not equal alternative hypothesis. So set up a suitable significant level. So having a set up a hypothesis as a next steps is to test the validity of H0 against that of HA to certain level of significance, either 5% level, but quite normal as a researcher test suitable level of significance as a 5% level. 5% level. So we have discussed later. Set up a suitable levels. We have very clearly is given for this hypothesis number 2. The procedure for setting suitable significant level. The distribution of sample means if the null hypothesis is true, all the possible outcomes. See that. So we have to see that it is a normal distribution curve. Normal distribution. This curve is called as normal distribution curve. Then left hand side and right hand side is we have to see that extreme low probability values. If H naught is true, then right hand side extreme low probability, we have to see these two things. We have to reject as well as the probability values of H naught is true. Then we have to find this system either accept null hypothesis if the sample statistics falls in this region. We have to see that setting up a suitable significant level, having set up the next steps to validity of hypothesis not done at the confidence level, we have to fix, and we have to find in this customarily expressed as a percentage such as 5% level. So the probability of rejection of null hypothesis is true. True, because we have to, when this hypothesis question is accepted at 5% level, this statistician is running the risk that is a long run. It may be by rejecting this hypothesis in the same level, he ran this risk of rejecting a true as the hypothesis is 5% out of every 5 out of every 100 occasions. So we have 100 occasion, you have to 5 along only for this rejection. So you have to put this the area in which 95% you have to accept level, only 5% you have to reject level. So this is the occasion we have to decision will make this wrong decision, but we have accept whether is out, we have to reject or vice versa. So this is we have to have 19% area, that area in which you have to be followed. This is a normal curve, but we have to put this middle point, that is 90% is whole. Then left hand side for we have to do 0.025 area. Then right hand side also 0.25 area, totally 5% level. So this is these diagrams. The above diagrams illustrate this, interpret the 5% level of level of significance. It may be noted that that is 2.58, 2.5, that 1% one area and the another one is another area. We have to see that. So this is setting a third one, setting a test criteria. So this is third steps of hypothesis testing. This procedure is to construct a test criterions. This involves selection on appropriate probability distribution. So from the beginning, I explained this sampling distribution. It is a probability distribution. Okay, so this is most important. So probability distribution as a statistics obtained from a larger number of sample drawn for a specific population. So this is most important for as a researcher. For sampling distribution is a population distribution. So we have to see involve this appropriate probability distribution for the particular test. The probability distribution which can be properly be applied, either it may be for inference that draws the sample distribution of the given population of the distribution of the frequencies of the range of the different outcomes it is required that would possibly to occur for the statistics of a population. So we have to see this setting of test criteria. Then we have test criteria. We have to commonly to use students might be knowing, is management scholars might be knowing, or commonly to use to test procedures. We have to know that T test, F test, I-square test. Okay, so this test criteria must employ an appropriate probability distribution. Employ appropriate. This is a parametric and non-parametric test. Then we have to employ. We have to use to employ to test the hypothesis in appropriate probability distribution. So because of a chance, we have to either a null or alternative. So for example, is only the small sample information is available, but the use of the normal distribution would be inappropriate for this purpose, and then you have to find out these solutions. Fourth one, doing computations. So we have having taken for the first 3 steps. First, for setting up of the hypothesis, set up the suitable significant level. Then third one, test criteria. How we are going to test the criteria, and that test the criteria for that make a difference. Difference that may be observed and expected. That is difference. The difference actually expected expected is less than that what is called 5% level significant or 1% level significant, then you have to see that inferences normally you have to find. So if the observed and if the difference between this observed and expected values is less than this 1.5996 standard error or 2.58 standard error, so the hypothesis of what is say hold on truths. So we have to find the system. So we have to obtain the system. Here we have to because this is value in which this is true. Okay, so this is we have to that kind of criteria we have to obtain for this calculation purpose. That making a decision we have to either reject or because of when you talk about the standard error, as a student might be knowing this standard error. What is standard error? So because the calculation includes the testing statistics and the standard error of the testing statistics. So what is the meaning of standard error? SCE, most important standard error. Maybe that error may be denoted in a deviation. Normally, when you calculation about deviation, I maybe for plus and minus and plus, the value is 0 deviation. But when you have a meaning of standard deviation, standard error, meaning of standard error, it means it refers to the standard deviation of the sampling distribution. Standard deviation of the sampling distribution. I already told what is the sampling distribution. It's a population distribution. Okay, so that is a probability distribution. That probability distribution for this, what is say that sampling distribution. What is standard error? That means standard deviation of the sampling distribution is called standard error. What is standard deviation? What is standard deviation? Anybody? Yes. So this means square root of the mean of the squared deviation. Square root of the mean of the squared deviation from the arithmetic mean. Isn't it? Note down. So this is most important. So we must know the standard deviation. Then only how to move to the standard error. The square root of the mean of the squared deviation from the arithmetic mean. Square root of the mean of the squared deviation from the arithmetic mean. So this is called a standard deviation. What is standard error? The standard error means the standard deviation of the sampling distribution. I already we discussed the sampling distribution. Okay, so we have to require for this some terminology is required. The probability distributions are required. Then only you have to see that the testing hypothesis for making this the criteria and all these things. Okay, so what is this? Square root. The formula I know that standard deviation is equal to square root of x. Sigma. Sum of squared divided by n. So that value observation is n. Observation is equal to x minus x bar. Okay, so the deviation is always we have to minus and plus. Then because of the middle value, the automatically the value will be 0. So we have to see that making a decision, then doing the computations. Having computations completely, we have to obtain a statistical test the performance of various computations from this random sample of size and for necessary for the test. These calculations include for testing statistics for standard error. So because we have to insist for this computations testing, we have to ascertain. Then making decisions. The company is making decision for that statistical conclusions or statistical decisions for this either to reject or accept the null hypothesis. It is most important region for this fifth step. It may be the null hypothesis false. Then we have to see that think that the sample results so rare that this significance and it cannot be explained by chance variations alone. So we can decide this reject H0 and state null hypothesis false. So, or the sample observations are not the consistent null hypothesis, either rejection or H naught automatically leads to acceptance of H naught. So, the other hand of 5% level significance observed set of these results and the probability as well as the more than this 5% level, then you have to see that given the reason the difference between this sample results and this hypothetical parameter can be explained, and also by the chances variations, and we have the result for this hypothetical test, it then maybe accept or reject decisions, making decisions. This one, this important 5 position for setting hypothesis. And then come to the next 2 types of errors in testing of hypothesis. When the statistical hypothesis is tested, there are 4 probabilities. Hypothesis is true, but our test rejected it. That is a type 1 error. Already explained in the last class, even though you will touch simply. The hypothesis is false, but our test is accepted. Type 2 error. The hypothesis is true, but our test is accepted. So correct decision. Hypothesis is false, but our test rejected. So correct decision. So this the first 2 is the type 1, type 2 error. It may be for some kind of we have possibility to lead errors. Normally possible to lead errors because they is given the error. Hypothesis is true, but our test reject. See, whenever this hypothesis is true, for example, this observed that there is a difference in this calculator value is less than the table value. So the hypothesis is true. But what it says, but our test is rejected. What this means? So there is a when you prove or accept in the sense what they want to say for that assumption. So there is no significant difference. No significant difference. Okay, so likewise, so when this hypothesis is false, but our test is accepted. So when this calculator value is more than the table level, that means observed value and expected value, the differences of observed and expected values is more than this standard error, which means plus or minus 5% level or plus or minus 1% level. That is a 1.96 or 2.58. Okay, that point, So we have referred the table. Then we have to see that hypothesis is false, but our test is accepted. So this is 2 error. Normally we leads to that. What is we obviously the first 2 possibilities lead to errors. Normally they have a error. Error it may be termed as a deviations. Isn't it? Deviations. But whereas in case of in statistical hypothesis, testing experimentations, type 1 error is committed by rejecting null hypothesis when it is true. The probability of committing the type 1 error is denoted by this pronounced as we have the what is say that alpha, where this alpha is equal to probability type 1 error, then probability is rejecting. And other hand, type 2 error is committed by not rejecting. That means accepting. So this is the null hypothesis when it is false. Null hypothesis when it is false. The probabilities of committing type 2 error. So it's denoted by pronounced as what is a theta, then alpha and beta. Okay, so the 2 terms we have to use for this purpose for calculating this types errors, and then we have to see that between the 2 types of error can made and this examples we have to arrive. But whereas when you calculations recording this hypothesis is true, but our test is accepted, this is a correct decision. Whenever you have to possibilities we have secured more mark. Okay, as a student of MCOM, secured more mark comparatively. We have a different subject comparatively. Previous semester, this semester secured more mark. So it's true, actually true when compared to others. First semester is students are more dull. Then compared to the second semester, students are somewhat quite normal or average, poor, normal or average. So in this case, we have to accept it. So we have to accept it. So our test accept this. This is a correct decision. Whereas the first 2, no, Kuiper is true, but is the result is what is rejected. Kuiper is false, our result is accepted. So these two things, the above two, obviously that is for you have to make a decision for that some kind of error. Whereas in this last two, for this researcher, we have to see that for statistical hypothesis, for research hypothesis, we have to see that this is true. See, students are having putting a vaccination, COVID vaccination, to safeguard their life. Maybe for 50% or 70% level, they have to safeguard their life if they may affect COVID. Simply, this is true. So it is a correct decision. It is a accept it. So this is as we have two things. The four statement. Two things you as a students you have to trust. You have to assumptions, assuming and formulating and interpreting your own state. Isn't it? So this is hypothesis false. The government of Tamil Nadu as education guidance department, they insisted to all the students and faculties, put a vaccination. Then only you allow the class, come to the office. Okay, but if you are not to do for following the rules, they want to be allowed the office as well in the office and the classroom, isn't it? So we have the commitment we have. Then only to safeguard your life. So this is information we have to share. The level of significance at the size of the rejection region, then you have to follow this system. Like next, two types of errors. See that. So we have two types of errors. True, but true about null hypothesis in population. True, false. Conclusions about null hypothesis from statistical tests. Accept null. Dr. Ganesha, sorry, Dr. Vinayamurthy.
Please, sir.
Yeah, okay. I am testing.
Okay, sir. Okay, sir. I'll be here, sir.
Okay. Is it clear?
Clear, sir. Super, sir.
Right. Okay, thank you. Okay. So two types of errors. We have that is statement. Now is what you call column and row. Then accept null hypothesis, reject null hypothesis. Type 1 error, type 2 error, false and true. So I have to see that. Test of significance for attributes. So we have a error in which two-tailed error, one-tailed error. Then we have 5% level, 6% level, significant level. Then you have to see that attributes, testing of attributes. Okay, the test of significance for attributes. We have to see the different tests of attributes because this is a vast area. And then even though I have to cover at my level test. So test of significance of attributes, the distinguished from variables where quantitative measurements of phenomena is possible in case of attributes. So association attributes, you know that association attributes in statistical methods, the association attributes male and female, that literate, illiterate, smoker, non-smoker. Likewise, that is attributes, alpha, beta. Likewise, that attributes the only this pressure or absence of a particular characteristics. Number one, test for number of success. Test for number of success. So the association of attributes, we have to find this. We have a 100 are found for literate, and in 1,000 in a village, maybe by rural people for 100 is illiterate and 900 is the total number of population 1,000. You assume that 100 illiterate and 900 is maybe literate. So in this way, you have to find 0.1 illiterate, 0.9 is literate, isn't it? So total 100. So this is for test of number of. We have to distribute that test for number of success, test for proportion of success, and test for difference between the proposition. So this is, we have to see that the sampling distribution of a number of success follows binomial probability distribution. Normally binomial probability distribution, the chance PQ probability, then 1 minus P is non-probability, isn't it? So this is, we have to see that means probability, that means 1 minus p is, it is called probability is failure. That is no. Okay, the probability of failure 1 minus p. Okay, now is 90% maybe for vaccinated in our university. 90% vaccinated means you assume that 100 90 vaccinated, 10 not vaccinated, so that they are failures for 90. That is 90 means p 1 minus p 10. So this is, we have to assume the probability of success in each trial. The number of success is required. As a normal day-to-day life, statistics play a major important role for, even though, so when you have a 100 rupees, you have to purchase 90 rupees vegetables and 10 rupees for other things, then you total 100. Then the probability how you're going to assess. So this is, we required for this. Maybe a coin was tossed 100 times, and the head turn up 80, the remaining 20 tiles. So this is n number 100 times the root of standard error, the root of standard deviation and sampling distribution. Okay, standard error, the root of n is equal to size of the sample, p is probability success in each trial, Q is equal to 1 minus p. So this is, we have to find the results. Next formula, you have to test the formula for what it says. This formula, PQ divided by N, test for proportion of success. Test for proportion of success. So standard error P is equal to square root of PQ divided by N. So population proportion Q is equal to 1 minus P is a number of samples from the population. So this is example, quite example. We have to see that from large basket found to be bad. So we have a 100 what you called apple in a one basket. 100 apple is packed and from Chennai to Karaikudi. 100 apple in one basket is packed. Okay, by through this transport, that boarding and taking, making and packing. Finally, you have to open this tomorrow. Tomorrow morning, you have to open at Karaikudi. The apple condition is only 90% good because of making and packing. Isn't it? 100 apple packed in one basket and sent to Karaikudi, from Chennai to Karaikudi. Then once you reach them in Karaikudi, then means that those who are place the order and open that basket. 90 is good condition. Remaining 10 is a bad condition. That is called, what it says, the test for proportion of success. So we have found to be bad. So we have to apply for this. About how many apples are bad condition? 10 apples. If I am in offline class, it will be more fantastic example, and chalkboard is excellent. So this out of 100, 10 is bad condition, worst condition. It may be for damaged. So 10 divided by 100. Excellent. So 10 divided by 100, that is that proportion 0.1. Okay. So this is P. Then remaining Q, that is what is say 0.9. So root of 0.1 into 0.9 divided by 100, then this is the result for the test for proportion of success. Isn't it? Next, test for proportion of success, I will explain. Then test for difference between proposition. Test for difference between proposition. That the difference between, then you have to see the different populations interested in finding out whether this difference between this proportion of success is significant or not. This proportion of success in one sample and standard errors of the difference between the proportion is called this formula. Then you have to apply for this two samples are drawn. Two samples are drawn from different populations. One from girls and one is boys. They are drawn these populations, finding whether the difference, the proportion of success are significant or not. So here 100 boys and 100 girls, they are drawing. So whether you have to success that proportions, you have to success or not. With this way of calculations, standard error, you have to apply this formula, then you have to obtain this results. We have a sample of 100 this in a town or maybe village, maybe 400 is found to be this consumptions of wheat, and another 600 consumed for rice. Okay, so what is the ultimate found results for this? To test the difference between these proportions, then you have to apply for the standard error P1 minus P2. So 100 members living this particular village, 400 have to actually they have to, consuming for wheat, and another consumed only for rice. Then the P1 wheat, P2 rice. So this is that difference. P1 minus P2. Then we have to the population. Then we have to arrive this system. And if there is any difference is more than this standard significant level. Most important to find the significant level. So that significant level for this tired error, the type of errors, rejection areas. The rejection area may be for 1.996% or 2.58%, but ultimately maybe for the whole area, leave this left and right. Why you have to leave the left and right? And really some assumption you have to find. We expect some damage. Likewise with rejection areas. Then only you have to find assumption for it. Maybe either void or maybe for invalid, or it may be. Okay. So this is a difference for that purpose. Either that regions both areas, left and right, small areas, we have to reject the regions. Then we have to find these results. Okay, so this is for the test for difference between a proposition for applying for this results, for applying this formula also. That's why significant of large samples. A large sample we have to find this system. For this purpose, we have to apply for this to compare observation with the expectations and to see how far this deviations of one from the other can be attributed to fluctuation of the sampling, to estimate from the samples some characteristics of the parent population, such means of the variables, the QH, the reliability of our estimations. So this is we have a sequence of large sample. When this large sample we have more than this, it may be the problems of sampling of variables, maybe as weight, height, etc. So which may take any true values. So I shall not. Therefore, it's possible for us to clarify each member of the samples under one of two heads. It depends the success or failures. So the range of the variables height and weight. So we generally have to easy to assess this correlation coefficients, which cannot be outside this range +1 or -1, right? You know very well the correlations. The correlation range, you know very well. What is the correlation? Anybody use correlation? Say the degree of relationship existing between these variables. The degree of relationship existing between the variables. So we have that ultimate results +1 or -1. The ultimate result correlation. Okay, so this is we have to obtain. It may be that range out from +1 or -1. So this is a main objectives and criteria. The difference between small and large sample, and you have to apply for this the sampling standard error of mean, standard error of mean, and standard of median, and all these things we have to find these results. The next two-tailed test for difference between the mean of two samples. Two-tailed test. If two independent random samples with n1, then you have to find this. And then we have some formulas applying for two-tailed test for difference between these means of two variables, two samples, and then n1 and n2, both sample size and greater than 30. So as a scholars, please you observing more and more. When you apply for this, the sample size is more than 30. Sample size of more than 30, then this formula you have to apply. So this respective we drawn this from the same populations of standard deviations, sigma 1 standard error of difference between the sample means is given this formula. Standard errors we have to obtain for this formula n divided by 1 divided by n1 plus 1 divided by n2 is if sigma is unknown, the sample standard deviations for compared to sample must be obtained for this purpose. If the sample says more than 30, then you have to apply. So for this population parameter, you have in your research work-life balance in your area, in your organization or organizational culture and climate. And the executives, how many of the executives are there? Who are the respondents? And again, I have to inform you. Then based on that, your study and frame the objectives. Then you have to do for the statistical tools. No need to apply for a job model, rotating model, raw model. No. Why you are applying for this model, rotating model, factor analysis? Okay, we are applying even though applying for parametric, non-parametric test. But what is your topic? What is your area, core area? What is your objectives? You have to prove the objectives, which tools you will be applicable to, and find the results through the hypothesis testing. Isn't it? And only as a researchers, you have to be concentrate on this part. So this is two difference between means, two means, x bar 1, x bar 2. So in this way, how you are going to do for seeing this means and all. If you have the two groups, boys and girls in the classroom, okay, so the boys may be for this x bar mean out of which 100 boys, 100 girls, then you have to see that you have to boys and girls 100, some standard deviation maybe, then numbers, then you have to find the results. Okay, why you are seeing these results for S1 and S2? S1 it represents sample 1, sample 2. Okay, so this is we have to find this system, and then we have to apply for this hypothesis, and then 5% level significance. Then we have to see or in 1% level significance. The difference x bar 1 and x bar 2, that is a difference from this one group and another group. Boys is x bar 1, girls x bar 2. Then you have to see the difference at 1% level or 5% level significance. Hypothesis, whether you have to test the hypothesis through this sample size. Say for example, for example, this formula, the result is obtained for 1 point something, but as a result, we have to refer that difference. Maybe for maybe more. For example, that 1% level, that value is 2.8, right? 1% level of significance, that value is standard error value is 2.58. So in this way, this is we have this values then compared to this differences. Then we have to obtain the difference between this. So this difference between that value is more and all. Then only you have to see the hypothesis reject or answer. And we have to see that if the two random samples with the x2 and standard deviations 2 and 2 respectively is drawn from this population, then you have to see that this is another formula which has to be used for this using standard deviation to do standard deviation. That is only for arithmetic mean. This is some advanced level standard deviation you have to apply for this purpose. When you are applying for standard deviation, it may be the deviation square root of this the square root of the mean of the squared deviations from the arithmetic mean. From this, you have to arrive this formula. The second stage of the formula for difference deviation, standard deviation, sigma 1 and 2 are unknown. So when S1 and S2 represent standard deviation of two samples, and can be tested with this, there is no significant difference in the means of two samples. So there is no difference. We have to obtain for this formula and all. So standard error difference between two standard deviations. Again, you have to repeat. Okay, and then student t-test. Student t-test. before student t-test, we have a small sample. List of significance for small sample. As a student, you have to see and why you are applying for this. What is say that student t-test. Okay. So some of the other we have to tell you yes. I mean post around 1915. Since published this finding under this as per the name student. Please understand student t-test. I like to introducing this part. The t-test was developed by W.S. Poshet around in 1915, year 1915. Since he published his finding under under uh, under a pen name student. So under pen name student. So it is known as student t-test. It is suitable for testing of significance of the sample mean or for judging the significance of difference between the means of two samples. When the sample are less than 30, so less than 30 in number, and when the population variance is not known, population variance is not known, and sample is less than 30, when two samples are related, the bad t-test is used. When this bad t-test is used, when the student t-test is used. Yeah, some of the scholar is quietly they are using for student t-tests. Why? Your sample size is more than 300, your sample size is more than 500, your sample size is more than 800, then why you applied for student t-test? Okay, this is totally, I mean, what is say, void. Meaningless. That is totally meaningless. So you have to thorough knowledge about the theoretical aspects, conceptual framework. You have to study about the statistical methodology. And only you have to move to the statistical tools. Many of them applied for t-test. So it's rightly pointed out when the sample size is less than 30, number one. Number two, the population variance is not known. Unknown population less than 30, then you have to see when two samples are related, then you have to apply for fair t-test. Isn't it? The population are known population, you have to register the population, then the directory of some officers, you have to collect the information, then your sample size more than 500, the students are applying for t-tests. That's the use. So this is student t-test. This is two important conditions. When the population variance are not known, the sample size is below 30, then only you have to apply for the student t-test. That is a bad t-test. So this is a formula you have to apply. That's most important. This is also used for testing the significance of the coefficients of simple and partial correlation also. So this is most important. Then you have to find this student t-test. The the test of significance, students, and then the test of significance, we have a parametric test. The significance used for hypothesis testing are the two types, parametric or non-parametric test. The parametric tests are more powerful, but they depend on the parameters or characteristics of the population. Parameters are characteristics of the population. They are based on the following some assumptions. We are using for parametric test. Observation or values must be independent. Value must be independent. Observation or values must be independent. That is most important. So the selection of one item must not depend upon the selection of any other item. Once you have to select one item, must not depend on the other item. So, if, for example, in organizational behavior, psychological aspects, we have an emotional intelligence, emotional test, emotionally. That is independent. I am emotionally. So emotionally I have, but emotional intelligence it is what is called independent, not dependent. Each and every individual should have emotional. That is their own. So there should not be that one item must not depend on the selection of others. isn't it? Like some kind of observations we have, which you have attitude, behavior, income level, income of the family, dependent. Okay, some kind of variables, independent. You identify the independent variable about your research, isn't it? So that is most important. The observation or values must be independent. So the selection of one item must not depend on the selection of the other item. Then only you want to apply for the parametric test. What I'm saying, students, what I'm saying, this insist this point, why you are when you are going to apply for the parametric test, isn't it? This that independent variable should not be depend on the another variables. Selection of the another one. Number two, the population from which the sample is drawn. Population from which the sample is drawn on a random basis. On a random basis. The population from which the sample is drawn on a random basis. Random sample. So we have two methods. Random sampling techniques, non-random sampling techniques. You know very well what are random sampling, what are non-random sampling. If people are, selected for sampling techniques for non-convenient sampling, adjuvant sampling, then you have to apply for parametric test. What is these things are? What things you have to do? You have to read and you have to imagine and you have to find meaning. Otherwise, you have some meaningless for your research. Isn't it? So some random basis, then only you have to apply the population from which the sample is drawn on a random basis. Then only you have to move to the parametric test for testing the significance for this hypothesis. So isn't it? So so that the arithmetic operation can be used. So that is most important, should be normally distributed and random basis alone you have to take for this the parametric test. Then another parametric test I will inform. So the population should have equal variance. Equal variance. Most important. The third important observations for applying for parametric test. Right. Then the data should be measured at least at interval level, so that the arithmetic operation can be used. The data should measure at least at interval level. It may be the interval level in the sense maybe for 5 or 10 or like this, 10 to 0 to 5, 5 to 10, like this interval level, and then you have to see that arithmetic operations. So these are the 4 important observations, assumption. Then only you have to select the parametric test from this test of significance and apply for this hypothetical tests through the significant levels. So and another important probability test we have to see that is a test, T tests and F tests. So this is for this. What is say that parameter test, Z test. Already we have discussed this standard error comes under this Z test, and then a T test. You know that student T test. This is student T test. F test you have ANOVA for F test. So take one by one this Z values showed that they represents experienced for this differently and their role in this as mothers and also the relationship with the parents and relatives. So we have some kind of values pertaining the difference between these mother roles and other sub role of housewives overall. So also we have to each occupational groups. So that value showed that represents experience for difference. That is we have some kind of role that is pertaining to the difference between this role of things. Then you have to apply for the Z test. Even this, what is the largest sample also for Z test. You have to apply for this. Then T test. T test. Just now discussed T test. When you are applying for this test, then this is for x bar minus mu divided by s n. This is a formula for applying for T test formula. Student T distribution large degree of small degree of freedom. Then we have to see this degrees of freedom in students' assumption, normal distribution for small size. According to degrees of freedom, last class some of them asked me for degrees of freedom, and then degrees of freedom which is relating to the various factors of hypothesis testing. That is a relation to various factors of hypothesis testing, which means it refers to the maximum number of logically independent values, which are values that have the freedom of uh, vary in the data sample. So in this, we apply for the chi-score test. Normally, we are applying for chi-score test. Chi-score test is a non-parametric test. Understand? Not parametric test is a non-parametric test. So when you apply for chi-square test, and then you have to see that degrees of freedom play a major role for testing the chi-square through this table value. Because it's a raw total and column total. It may be for what is said that R minus 1, C minus 1, isn't it? How many row, how many columns, then you have to detect 1, then n minus 1. This is a formula we apply for degree because they refers to the maximum number of logically independent values. Values which are values that they have a what you say that freedom to vary in the data sample. So this is most important for applying this chi-square. Degrees of freedom. Then you have to apply for this test. Most important, this is what is called the properties of student t-test. What are the properties? Most important. And from this, we have to apply the variables. The variable of t distribution range from minus infinity to plus infinity. So this is one of this. That is chart. You have to find minus and plus infinity and plus minus infinity to plus infinity. That is what we call the plus or minus 1 minus 1.96 plus or minus 2.58 like this. The constant c is actually the function of mu, not this. V means freedom. The distribution of f t is completely specified. Is family of functions. Then one for each values of v. Okay, v. So this is we have to find this student test with the help of taking this formula and obtaining for either 99% level or 95% level limit. Then you have to apply for a t test. Then we have to see that results. The standard normal distribution, that t distribution is symmetrically and has mean 0. So this is we have to obtain for that. Likewise, this normal distribution, the distribution is symmetrically and has a mean 0. So this is we have to apply for this formula for each property. One of the property for this sample size, maybe for n is equal to 15 or t distribution sample size maybe for n. The normal distribution sample size we have to apply this curve like this. Next properties, the variance of the t distribution is greater than 1, but the approaches 1 as the number of degrees of freedom, and therefore the sample size become large. So when we find this, therefore sample size become large, the variance of the t distributions and approaches various standard normal distributions, and we have the degrees of freedom, and we have to see that row minus 1, column minus 1, then you have to apply this formula. Finally, you will get it. And we have the degrees of freedom, then you have to apply for against the widely practiced rule of thumb that the sample size sample size n is greater than 30, n is greater than 30, may be considered as a large sample, and that n is less than 30 is considered small sample. Okay, and this and then standard normal distribution may approximately are used for this property, and we have the distribution system. We used as that approximation of the distribution later theoretically at functional forms. So this is we have to see the t table is the probability is the integral part of the d distribution, and it gives this the range of values at this probability of exceeding by chance value of t at the different levels of significance. So normally we have to see if n means there's an size. N means size of the population. Okay, when this n is greater than that what is called 30, n is greater than 30, then you have to apply for larger sample. When n is less than 30, then you have to move to this small sample. Then you normally by chance the probability of exceeding by chance value of t at a different level of significance. The t distribution has different values. T distribution has a different value for each degree of freedom. Degree of freedom. So I told this degree of freedom. Then you have to as the meaning. We have to refer to the maximum number of logically independent values, which are values that have freedom to vary in this data sample. So then you have to apply for this degrees of freedom. Then you have to application of t distribution is equivalent to the normal distribution. Normal the mass, the distribution curves. Okay, x bar mu z. So we have to find this normal distribution equal to normal distribution. So z distribution standard normals. T distribution is n is close to 30 is smaller. So we have different colors. You understand this distribution property of t distribution. So then distribution n is close to smaller z distribution standard normals. Then you have to apply this formula. I'll explain this infinitely large. The end of probabilities integral of distribution, it is over a range of values of mu p range, and then we have to see that it gives these values degrees of freedom. The probability of exceeding by chance value of that value of t at different levels. So that t distribution has a different level for each degree of freedom, and when degrees of distributions are indefinitely large, the distribution is equivalent to normal distribution, and the probability is on this normal distribution, like this t distribution. Next, the level of significance. Why is again the application of the t distribution. So how you are going to apply for the t distribution to test the significance of the mean of the random sample in determining this whether the mean of the sample drawn from the normal population deviates significantly from this standard values hypothetical of the population means. This is we have to see that number one, to test the significance of the means of random sample. So this is way in which you have to see that in determining whether this mean of sample drawn from this normal population, deviates significantly from the standard values, that is hypothetical values of the population's mean. Then applies formula is there is t is equal to x bar minus mu sigma x bar. Okay, so we have to see that values like standard error of mean out standard this mean of the sample mean of the universe populations. Then why you are applying for this? We have to see that we have exceed if the calculator value of t is exceed. Say that the difference between x bar and mu, the significant 5% level, and if you exceed the difference between 1% level, we conclude that difference between this x bar mu are not significant levels. That might be see this formula for within mu is equal to mu. So this is we have to see that this purpose for that calculation, and we have to ascertain this Hypothesis means random. We have to find these results either maybe for the values in appropriate test statistics set level. It may be for either maybe this level or maybe that when you apply for the degrees of freedom. Then refer as a table value. Then you have to find this random sample. The random sample may be for using this test sample size of 16 or maybe me 53 as maybe as a mean. Then you would apply for this. Okay, random sample and sample of size and mean. Okay, so random sample and size are mean. Random sample is what is say, 50. Maybe it's mu. Mu means we have what is say, we have to given this system like finding what is okay having this mean. So from the taken from the mean population mean to understand the mean. So the X bar is a mean of the sample, mean of the universe population. It's a taken from the mean is a mean of the sample, random sample of mean. The random sample of mean is X bar taken from the mean as a mu. X bar is a uh, random sample taken from the sample mu. Okay, so then you have standard deviation. You have to apply for this significance level. Why you are applying for this t test is more than this that value. So calculated values of t test is more than the table value. So the hypothesis is rejected normally. So against the sample has not come from this population. So when calculator value of t-test is more than the table value, hypothesis normally is rejected. So we have standard table value. Beyond the table value is rejected. Then once rejected, it is a gold good. So there is the samples has not come from this part. Testing difference between mean of two sample independence. So testing difference between means of two samples independent. So this is another t-test formula for this x power 1, x power 2, standard deviation 1, standard deviation 2, ion plus n. So this is we have to apply for this for the hypothetical testing. Why when you are applying for the testing like we have two types of drugs used in this essence normally. Two types of drugs are used to this people. Patients are for reducing their weight. People are using for two drugs. For people are using and reducing the drugs. Apply for this T test. Then you have to find the results. Ultimately, you will find. When you talk about this non-traumatic test, we are using this before that what you say that F test F test also sorry what to finish it this one dependent sample testing difference between means of two samples. Dependent samples are matched paired observations. So formula for this what is say two different observations from this test we have to apply for this when the samples are dependent they comprise the same number of elementary units. Then you have to apply for this formula the efficiency of two trucks one made within this country and another imported. So when compared to these two you have to apply for this formula for t is equal to t dash minus o or you have to apply for this t is equal to t dash and root of n divided by s. So to verify whether this course accounting improve this performance, to verify accounting improve performance similar test was given to 12 participants both before and after, sometimes maybe after and before. Then you have to apply for this testing difference between means of two dependent samples and observed frequencies. Then testing of significance of observed correlation coefficients. Then we have to test significance of the correlation coefficient to test can be used to test for significance. We have to this testing of significance. So they given this random sample from this private bivariate normal populations. We are using for this test hypothesis for the correlations. Coefficients of the population is 0. That is the variable of the populations we have to find are uncorrelated. We have to apply the following tests. Okay, R is correlation coefficient, then root of n minus 2, then divided by root of 1 minus r square. So we have to apply for 5% of t test with the help of this correlation. I already informed this correlation coefficient. The correlation, the degree of relationship existing between these variables. Then you have to apply for this R. Normally you apply for the R. Then that relationship between income and expenditure or demand and supply and we have. And disturbance. Hello, mute your mic. So then we have to finally how to arrive this test on finding this conclusion inferences. That we have some ANOVA F test for this parametric test. Leave the parametric test and ANOVA test we have to apply for this F test. This is denoted as F distribution. That is distribution is skewed to the right. Hello, mute your mic and to be more systematically, and we have to see that the degree of freedom for this numerator and denominators increases when mean more than 2. X bar is more than 2. You can apply for that what is ANOVA. Various are 2 independent variables. Then you have to use the analysis of variance. Then you have to find the test the significance of more than 2 variables. 2 sample means. Then it also to use for judging the significance of multiple regressions also. Remove this non-parametric test. Then it is most important for the non-parametric test. That is we have chi-square test. So chi-square test, you know very well that observer is most popular non-parametric test of significance in social science research. And then we have it is used to make this comparison between 2 or more nominal values. So unlike the other test of significance, chi-square test used to make this comparison between frequencies rather than between this mean scores. This test is evaluated whether the difference between the observed frequencies and expected frequencies, most important. And this null hypothesis can be attributed to chance or actual populations differences. So the chi-square test you have to apply this, because when you apply for this chi-square test, then you use a non-parametric test. Two or more nominal variables. Unlike the other area of test of significance. So we have to observe frequencies, then you have to calculate for expected frequencies in terms of null hypothesis. Then you have to apply for this null hypothesis. You have to apply for this how you're going to apply for the expected frequencies. We have a row total in multiply with the column total divided by this number of total. Row total multiply with the column total divided by the n. N means total, number of total. Then you'll get it this expected frequency for each and every cases. Then in the null hypothesis we have to ascertain this. There is no significance difference the 2 educational categories. For example, the educations for low, high, and we have income level low and high. Then we have to see the 2 education categories in their pattern of income level. That is the person with the low education and the person with the high education, then is expected to have the same proportions or high level or income level. So that is a research hypothesis, most important for each and every case. As a researcher, you have some research hypothesis. There is a relation between educational and income level. Educational and income level. This is hello.
और राजपूत भी एक्सपर्टी है क्या?
That we have finding this we can compute this expected frequencies for this non-parametric test of chi-square test. So within this testing of significance of the observed and correlation coefficients, then you have to find this ultimate results. That results may not be may more than 1 point. Either +1 or -1. It is hold good for this null hypothesis. Thank you. This is we have a hypothesis testing 2. We have any clarifications and queries, please you. Nayamurthy,
Sir,
Dr.
thank you very much,
Nayamurthy.
Professor.
Yeah.
Thank you, Professor. Dear participants, this is a time for interaction, please.
So this is for totally, what is say, technique which is relating to the problems, how to solve, how to make it hypothesis while applying for statistical tools. Hands-on work is important.
है
Rather theory items, theoretical, information you would apply for the system, then it is most useful for compared to teaching, normal teaching. When you have to use for this system, then you have to do for some exercise. Why you are applying for this parametric test? Why you not applying parametric test? Why you are not applying for t-test? When you are applying for the correlation like this, it will be more useful for at the time of for using this system, laptop or maybe hands-on training. It will be more useful. My observation. Anyhow, this is my level. I have to do. Covered entire
Sir,
hypothesis.
excuse me, sir.
Yes.
Sir, it is very informative. Can I ask a small question?
Yes. Welcome. Your good name, please.
When we can test this hypothesis, is it for null hypothesis or research hypothesis or for statistical hypothesis? When
Yeah,
one
yeah.
can test?
Yeah. See, when you have chi-square test, many of the researchers are using for hypothesis and test, chi-square test. Many of the, so we have that is we have distribution of the, for example, distribution of income by education. We have a low, high, and maybe the income level low and high. Education also low and high, income also low and high. In this way, then we have to test hypothesis for apply this formula. O minus E, isn't it? So divided by E, that means expected frequencies. Then you have to apply the as a result. Then we have to get the result. Then there is no significant. When there is no significant difference between these two education categories in their pattern of income level. When you move to this for research hypothesis, there is a relations between educational and income level. Likewise, when you have you observe for that type 1, type 2 error, isn't it? So that error we have first the last two we have normal, but obviously there is a error in between these two. When hypothesis is true, but it is rejected. When hypothesis false, it is accepted. Whereas when hypothesis is true, it is correct. Hypothesis false, it is wrong. So that is we have a four type of theorem while selecting for this hypothesis testing. Even though we have to apply for that significant level, with the help of the significant level, and then you have to do most appropriately. I observed this many research textbooks and standard reference books exclusive for research. 5% level significant is quite normal. 5% because it is required for each and every aspects. That 5% level are more useful for that researchers because that is what is that 1.96 level, the significant level, then you have to see that this criteria for normal criteria for accepted area is where maybe 95%. Then reject area 2.5, 2.5. Then you have to see the results amicably and come to the conclusions. But when the last class I insisted very strongly, then you have your topic, your research topic title, then you have to frame your objectives, then you have to each and every objectives you have to do for that testing the hypothesis through the statistical tools. Then only your results full-fledged for obviously.
Thank you, Professor.
Yes.
Sir,
Thank you,
thank you.
participants. Now this is the time for a vote of thanks. I request and invite Dr. Kanagavali Madam to deliver a vote of thanks. Please, Madam.
Thank you, sir. I feel honored and privileged to propose vote of thanks on this occasion. I may like to express our sincere thanks to Professor C. Vedirajan sir, Professor and Head, Department of Corporate Secretaryship, Alagappa University, for giving an excellent coverage to hypothesis testing, valuable and very informative session, sir. Thank you, sir.
Thank you.
Thank you all faculty members and all participants. Thank you one and all. Thank you.
Dr. Vinayamurthy.
Thank you very much, Professor.
So
Amazing
this
presentation,
today is a very auspicious day.
Yes, Professor.
We are spending for this academic excellence.
Yes.
So I am very much thankful to the Department of Commerce,
Thank you, Professor.
that the coordinator of this program, Professor T.R. Kurumurthy sir, and Deputy Coordinator Dr. Vinayamurthy,
Thank you, Professor.
and given this opportunity today. Today's Vinaya day, this session. So I am very much happy and sharing my my experience. Experience to do this hypothesis part. That participants, any observation, please? I like to know, because I covered the first part is theoretical part, second part is totally for application oriented. It is required for hands-on training.
Dear participants,
Yeah, hands-on training is required, but I need some observations because
what is your feedback, please?
yeah.
Share your observations.
Sir, it's a very informative session. We learn a lot, sir, new things from you. Thanks for valuable and informative session, sir.
Thank you, sir. Please, sir, please. Yeah. Okay.
Hello, sir.
Good afternoon, sir.
Yes.
Good afternoon, sir. Good afternoon, sir.
Sir, I'm
Please, one by one.
Mangalore
One by one.
University.
Please,
It
one by
was
one,
very
please.
informative session, sir. I'm research scholar from Department of Commerce, Mangalore University. Sir, I have one question, sir.
Yes, welcome.
Sir, if null hypothesis is accepted, whether it is wrong, sir?
No, not wrong. That is rule of thumb. Rule of thumb we have system, and then you have to do for that. When is null hypothesis accepted? When this calculator values you have. When calculator values are.
Value. Yeah.
Tell me. Calculator value is less than the table value. That is a
Yes.
And then for that formula it will vary from this another. For example, in the level of significance for applying for standard errors, expected and observed, the difference between expected and observed of is more than the 1.96 standard error. In this case, hypotheses are rejected. So when you have a standard value, when you move to this chi-square test, the table value standard, calculator value also we are calculated. So calculator value is less than the standard table value, then the hypothesis is accepted. This is a rule of thumb. But what it says is that the format the statement what it says. When this hypothesis is true, then the outcome is rejected. When the hypothesis fall, the outcome is accepted. This is a one part. Another part, when hypothesis is true, that outcome is accepted. When hypothesis false, the outcome is rejected. This is another part. What I'm saying, the first two is for your research purpose. The rest of the third and fourth we are applying for our human life. When you say this is correct, sir, yes, sir, correct. Why you are moving to alternative? Because alternative is one part. Alternative. So we have to toss a coin 100 times. Then we have to expected our outcomes. Maybe for 75% hit 20% time. Isn't it? That is a possibility and probability. Therefore, I explained for sampling distribution, population distribution, and then what is called standard error, standard deviation, like that. Then that conceptual clarity I explained in this class. Thank
Okay.
you. Anyhow,
Okay.
Sir, good afternoon, sir.
Yeah.
Good afternoon, sir. Sir, thank you much for giving the information, sir. It is very useful to my research, sir. Sir, I have a small query, sir.
Yeah.
Sir, I am Srinivas, sir, University Tamil Nadu, research scholar, sir. Sir, actually, my research topic is use pattern of electronic sources of medical professionals in Andhra Pradesh, sir. My total population is 2,400, sir. Sir, can I take 50% as a sample? Which sample technique is more useful for us, sir? My research.
But not your topic is not clear. Some voice maybe. Others please mute your mic. Others please mute your mic. I hope to clarify your doubt. No issue. Your topic is, what's your topic?
Sir, use pattern of electronic resources by the medical professionals, sir, in Andhra Pradesh.
Medical
Medical professionals, sir. Medical professionals.
medical practitioners.
Yes, sir. Medical students and faculty members, sir.
Wait. So this is your population is definite population. I'm right.
Yes, sir.
Definite. From your area, geographical area, Andhra Pradesh.
Yes, sir.
Okay, good. But how many districts are there? But totally Andhra Pradesh, how many districts?
2,400, sir. Total population strength.
Yeah. Then you have to take some percentage.
Yes, sir. 50% is. I will take 50%. 50% of total population.
So 50% is more than 1,000.
Yes, sir.
Up to 500 something, 500 to 600 sample size you have, then only you will be, your research will be good.
Okay, sir. Thank you, sir.
No need thousands. Otherwise, bias will come. Biased.
Yes, sir.
This bias will come. More than 1,000 bias will come. Then up to 500, 600 is good. Old good. Your result also old good. So that you have to apply for formula. And then because your population is a definite population, no doubt, because everything is registered and collected information from the medical, director of medical office, and then your district also.
Yes, sir.
Then you have to apply for this population, and you have to see the selection of population, apply the formula along with some percentage you have to calculate it, and then come to this 500 to 600 is whole good use sample size. Medical practitioners, medical and maybe statum may be applied. Stratified
Okay.
sampling may be applied.
Okay, certified sampling, sir.
Yeah.
Okay.
So this is most important for parametric, non-parametric. Why you are applying parametric, non-parametric, and then fix your objectives, coin your objectives. Based on the objectives, you apply for statistical tools. Then you have to move to the testing of significance. Finally, you come to the result for hypothesis. Hypothesis is for conclusion. Okay.
Okay, thank you. Thank you very much, sir.
Yeah. Thank you.
Thank you, Professor.
Yeah.
Thank you very much,
Yeah.
Professor.
Yeah.
You are making this session a highly interactive session, Professor.
Yeah. With your all over. I wish you all a happy Vinaya Chaturthi. Thank you.
Thank you, Professor.
Yeah. Bye.
Thank you very much, sir. Thank you very much, sir.
Thank you, participants.
Thank you, sir.
all. We'll meet tomorrow morning, 9:45. Thank you.
Thank you, sir.
Thank you so much, sir.
Thank you, sir. Thank you very much. Thank you.